Hello, my name is Hisham Hamid, and today we're going to be talking about matrices. But before I jump in, I want to give you a brief overview on matrices history. So the history of matrices goes back to ancient times, but the term matrix was not applied to the concept until 1850 by James Joseph Sylvester. Matrix is the Latin word for womb, and it retains that sense in English. It can also mean generally any place where something is formed or produced. The origins of mathematical matrices lie with the study of systems of simultaneous linear equations. An important Chinese text from between 300 BC and 200 AD, 9 chapters of the mathematical art, and its Chinese name, Chu Cheng Suan Shu, gives the first known example of the use of a matrix method to solve simultaneous equations. Now let's talk about the application of matrices. So a very simple use for matrices is, let's say if you're a store owner and you want to organize the 3 different kinds of fruit that you have. You have apples, oranges, and bananas. And you want them to be all neat. So one row you have your apples, one row you have your oranges, and one row you have your bananas. It's really that simple. That can be a matrix. So matrices have many practical applications, such as matrix mathematics applies to several branches of science, as well as different mathematical disciplines. We see the results of matrix mathematics in every computer-generated image that has a reflection or distortion effect, such as light passing through rippling water. So if you look at, let's say, a video game and you see a man swimming through water and you see the light shining at him and it's moving, that is the result of a matrix. Before computer graphics, the science of optics used matrix mathematics to account for reflection and refraction. Matrix arithmetic helps us to calculate the electrical properties of a circuit with voltage, amperance, resistance, and many other applications in the electrical field. In mathematics, one application of a matrix notation supports graph theory. So pretty much, matrix mathematics simplifies linear algebra, at least in providing a more compact way to deal with groups of equations in linear algebra. Instead of having these big equations out there, you can minimize all of them and put them into kind of one bracket, which would be that matrix. A matrix organizes a group of numbers or variables with specific rules of arithmetic. It is represented as a rectangular group of rows and columns.
So this is what a matrix looks like. Here we see that there are 3 numbers going this way and 3 numbers going down this way. This would be 3 rows and 3 columns. So this is called a 3 by 3 matrix because of that.
So now that you know a little bit about matrices, I'm going to show you how to solve a simple matrix addition problem.
So this is a matrix addition problem. Here we have a 7, 5, 8, 9 plus 3, 6, 7, 4. What we're going to have to do is we're going to have to add each value up. So 7 to the 3, 5 to the 6, 8 to the 7, 9 to the 4. And that gives us 10, 11, 15, and 3. It's really that simple. Now, the same approach can be used for multiplication and subtraction. So here we have a matrix multiplication problem. We have 7, 6, 8, 4, 9, 3, 2, 1 times 5, 8, 3, 2, 2, 7, 1, 9. So just as I showed you with the addition, you're going to get one of the numbers, put it with the corresponding number on the other side, and so forth. And your result will be this: 35, 48, 24, and 8, 18, 21, 2, and 9. So that's what it is when you're multiplying with matrices.
So now that we know a good amount about matrices, you should try to challenge yourself. Try adding more rows, more columns, try dividing, squaring. There's so many different things that you can do to matrices, and there really is no limit. Just try something new and try to push yourself and find a new way that you can use matrices. So I hope you guys enjoyed the video. If you really liked the video, please let me know in the comments below and give the video a like, and let me know if you guys want me to make more math videos. Thank you.